Hey everybody, so this video is going to be about working with radicals. This is the first in two videos about this, and we're going to focus on simplifying radicals, multiplying radicals, and adding and subtracting radicals. Okay, so the first thing I want to do is review the properties of radicals that are the most helpful to us in these topics. Okay, so okay. Because we know that radicals are really fractional exponents, each exponent rule gives us a different property of radicals, but we're going to focus on two of them that are the most helpful. Okay, one of them is the way that you multiply radicals together. Okay, you will notice that these have the same index. Okay, you can combine them by multiplying the radicands. Okay, if you think about this property in reverse, this means that you're allowed to split up the radical over a product. Okay, the second one that we use is with a fraction. Okay, so if you have a fraction inside of a radical, you can split it up into numerator and denominator. Okay, the reverse of that would be if you are dividing two radicals, you can create a single fraction within the radical. Okay, all right, so let's look at some examples of simplifying. You guys should already be familiar with simplifying square roots. If you find that you have forgotten about that or you weren't that familiar with this to begin with, please watch some of the extra videos that I've posted. Okay, so we're going to simplify. Okay, so the first thing I'm going to do here is use the first property that we said to combine this into a single radical by multiplying the radicands. Okay, so 18 times 2 is 36. Okay, and then x times x cubed is x to the fourth. Okay, and then we're actually going to take the square root here. So the square root of 36 is 6. And the square root of x to the fourth is x squared. Okay. All right, let's look at another example of this. Okay. So again, we're going to multiply these by multiplying the radicands. Okay, so 6 times 15 is 90, is that right? Okay. And then x times x cubed is x to the fourth. Okay. Now, just like before, we can take the square root of x to the fourth and get x squared. Okay, but when we take the square root of 90, we'll see that it doesn't come out evenly. Okay, so in order to simplify this, we're going to split up into the part that is a perfect square and then the part that's left over. Now, we already said that x to the fourth is a perfect square. Okay, then we're going to look for something that is a divisor of 90, right? Something that divides 90. That's a perfect square. Okay, well, 9 is a perfect square and it divides 90, so I'm going to use 9. Okay, and then what's left over is 10. Okay, so here's my perfect square part and here's my leftover part. Now I'm going to split this up, so I do square root of 9x to the fourth, okay, times square root of 10. Well, the square root of 9x to the fourth is, this was actually chosen so that this would come out evenly, right? So the square root of 9 is 3. Square root of x to the fourth is x squared. Okay, now the square root of 10 does not come out evenly, so we would leave it like this. Okay, Now, we know that this is done simplifying because there are no perfect squares besides one that divide 10, right? So you just check the perfect squares that are less than 10. So 1 doesn't count, right? 4 doesn't divide 10, and 9 doesn't divide 10. And those are the only perfect squares that are less than 10. Okay. All right, let's look at one more like this, and this one is a little bit trickier. Okay, now it's tempting to students to want to split this up into the square root of 16 minus the square root of 4 minus x squared, and that is absolutely wrong. Okay, I'm going to write this in red because it's incorrect, and I will put no. Okay, so you cannot do this. Okay, and then get 4 minus 2x. Okay, this is not true. It doesn't work like that. Okay. All right. So let's look at what you can do, right? So what we want to do is factor out something here that's a perfect square. So we're looking for something that divides 16 and 4x squared that's a perfect square. Okay, now one thing that I can see that divides both of these is 4. So I'm going to factor out a 4. Okay, and then I can split this up. So I can split up square root of 4 times the square root of 4 minus x squared. Okay, now I know the square root of 4 is 2, so this will give me 2 root 4 minus x squared. Okay, there is nothing else you can do to simplify this. You cannot split these up. You absolutely can't. You can't say that this is 2 minus x. It isn't. Okay, so you can split up the radical here because this is a product, right? Multiplication. You can't split up the radical here because this is subtraction. Okay, so you can split up radicals with multiplication or division, but not with addition or subtraction. Okay, so now that we've done a couple examples with the square root, let's look at the cube root. Okay, so with the cube root, we're certainly not looking for things that are perfect squares, right? We're going to be looking for things that are perfect cubes. Okay, now we definitely can multiply these in the same way by multiplying the radicand. Okay, so this would be cube root 9 times 6 is 54. Okay, and then x times x squared is x cubed. Okay. Now we are looking for something that is a perfect cube. Okay, well x cubed is a perfect cube. Okay, but we are also looking for something that divides 54 that's a perfect cube. Okay, so we might do that using a factor chart. Now we know this is 9 times 6, that's how we started. Okay, so that gives us 3 and 3 and 2 and 3, right? So you can see 1, 2, 3 that there is a perfect cube, right? 3 times 3 times 3, or 27. So here's my perfect cube coming from this factor that's repeated 3 times. And then my leftover part is this 2. Okay. All right, now I'm going to take the cube root of this part. Okay, the cube root of 27x cubed is 3x. Okay, and the cube root of 2 doesn't come out evenly, so I'm going to leave it exactly how it is. Cube root of 2. Okay, and I can tell again that this is fully simplified because there's no cubes that divide 2. Okay, all right, let's look at another example like that. So again, we are going to multiply these two together by multiplying the radicands. Okay, so that would give me cube root. Okay, now I don't even know what 49 times 7 is, but I do know that it's 7 times 7 times 7. Okay, so if you wanted to know the numerical value, you could certainly write it out, but I'm just going to write 7 cubed because that's what it is, right? 7 times 7 times 7. Okay, n squared times n squared is n to the 4th. Okay, and then I'm going to split this up into two parts, right? The perfect cube part. So minus 7 cubed is certainly, oops, need my radical. Minus 7 cubed is certainly a perfect cube, right? And n cubed is a perfect cube. Okay, so what's going to be left over? Okay, I have this minus 7 cubed, I have n cubed, there's one n left over. Okay, so I can split this up. Okay, now here, minus 7 cubed, take the cube root of that, you're going to get minus 7. Okay, cube root of n cubed, that's n. Okay, and I'm going to get cube root of n. Okay, so again, we're splitting it up into the part that goes evenly, perfect cube part, and then the part that's left over. Okay, another example. Okay. So a lot like part C from the first example, when you have an addition like this, the only thing you can do is factor something out. Now I'm looking for something that divides a to the 12th and a to the 6th, okay, and that's going to be a to the 6th. Okay, so this will leave me with 8a to the 6th plus 1. Okay. Now I can split this up, but I can only split up the multiplication. So this will give me the cube root of a to the 6th, right? And then the cube root of 8a to the 6th plus 1. Okay, remember from the previous example that I cannot split this up because of the addition. Okay, so the cube root of a to the 6th is a squared. Okay, and this cannot be simplified further, so I'll be left with cube root 8a to the 6th plus 1. Okay. One more example. Okay, now we're going to multiply these by multiplying together the radicands the same way that we always do. Okay, so we'll get 4th root. Okay, 16 times 4 is 64. Okay, x to the 15th times x to the 12th, we're going to add the exponents and we would get 27. Okay. Now we're looking for something that is a 4th that divides 64. So again, we can always use a factor tree. Okay, so this came from 16 times 4. Okay, so this would be 4 and 4. Now this is a cube, okay, but that's not helpful because we're looking for 4ths. So we're going to split it up more. Okay, so this would be 2 and 2. This is also 2 and 2. This is also 2 and 2. Okay, so I'm looking for a group of 4. So here I have 4 2's. 1, 2, 3, 4. Okay, and then here's my leftover part, 2 2's. Okay, so when I split up the number, I'm going to be looking for this, which is 2, 4, 8, 16. Okay, and then my leftover part is going to be 2 times 2, or 4. Okay. Now for the x to the 27th, right, we're looking for something that is a perfect fourth power. Okay, remember the fourth root is the same as the 1/4 power. So the things that are perfect fourth powers are going to be things that are divisible by 4. So I'm looking for an exponent that's divisible by 4. Okay, well 24 is divisible by 4. Okay, and then how many are left over? Well, there was originally 27, here there's 24, here there will be 3 left. Okay, so you're looking for the largest exponent that's divisible by 4, but is smaller than 27. Okay, now here, the fourth root, oh, we'll split this up. Okay, so the fourth root of 16x to the 24th. Well, the fourth root of 16 is 2. The fourth root of x to the 24th, remember you're going to divide the exponents, so that would be x to the 6th. Okay, and then this does not come out evenly, so you just leave it. Fourth root of 4x cubed. Okay. All right. Now that we've done a ton of examples of simplifying and also multiplying, we are going to look at some examples of simple dividing, simplify. Okay, so the first thing we're going to do is turn this into a fraction so that we can actually reduce the fraction. Okay, so we're going to be using that second property of radicals, where you can change from the division of two radicals to the square root of those two things divided. So we'll get 45x cubed y cubed over 5y. Okay. Now I can reduce this, right? 45 divided by 5 is 9. Okay. And then here I would subtract the exponents. So 3 minus 1 is 2. Okay. Then I'm going to split up my square root into things that are perfect squares and things that are left over. Okay, so 9 is a perfect square. Okay, x cubed is not a perfect square, so I'll take x squared out and I have a leftover x. Okay, and then y squared is a perfect square. Okay, separate them. Okay, and now I can take the square root. The square root of 9 is 3. The square root of x squared is x. The square root of y squared is y. Okay, and because this doesn't come out evenly, we're just going to leave it alone. Okay. All right, let's do one more like this. Okay, and we'll do one with a cube root instead of a square root. Okay, so just like the previous example, the first thing I'm going to do is turn this into one big cube root so that I can reduce the fraction. Okay, and then I'm going to simplify this using my exponent rules. Okay, so that would give me the cube root of 8b to the 5th over a to the 6th. Okay, now I'm going to split into things that are perfect cubes. So 8 is a perfect cube, right? 2 times 2 times 2. Okay, b to the 5th is not, because remember we're looking for exponents that are divisible by 3. So the biggest exponent that's divisible by 3 but is less than 5 is going to be 3. So I'll have 3 here, and then I'll have 2 left over. Okay, and 6 is divisible by 3, so this is also a perfect cube. Okay, now I'm going to split it up. Okay, now here the cube root of 8 is 2, the cube root of b cubed is b. Okay, cube root of a to the 6th is a squared. Remember, you are dividing the exponent by the index. Okay, and then here I am still left with the cube root of b squared. Okay, all right. So now that we've done some simplifying, let's go ahead and do some examples of multiplying. Okay. The work is largely the same. Okay, so you'll see that it's not too different than what we've been doing. Okay. Now, the first thing that we can see is that we're going to need to distribute this. Okay, so I'll have root 2 times root 6. Okay, and then from distributing here, I'll have root 2 times root 10. Okay, now I know how to multiply these. I multiply the radicand, so this gives me root 12 plus root 20. Okay. Now I'm going to look for something that's a perfect square that divides 12. So a perfect square that divides 12 is 4. Okay, and I'll do the same thing for 20. A perfect square that divides 20, that's also 4. So I'll have 4 times 5. Okay, square root of 4 is 2, so I'll get 2 root 3. Okay, and same thing here, this will give me 2 root 5. Okay, because these are unlike terms, okay, that means that I am done with this example. Okay, just to remind you about what makes something alike terms, okay, for radicals specifically, okay. Okay, so radicals are like terms if they have the same index, right, meaning they're the same type of root. Square roots can only be like terms with square roots, cube roots can only be like terms with cube roots, etc. Okay, and they have to have the same radicand. Okay, so that's what's the problem with this one. Even though they're both square roots, they have 2 different radicands, so they are unlike. Okay, let's do another example about multiplication. We'll do one with a cube root. Okay. Now we're going to multiply these two together by multiplying the radicands. Okay, so 2 times 20 is 40. Okay, and then we'll do the same thing. That's from this. Same thing here. Okay, so we'll get minus 2 times the cube root of 2 times 12, or 24. Okay. Now we're going to look for things that are perfect cubes that divide our radicands. So something that is a perfect cube that divides 40 is 8. Right? 40 is 8 times 5. Okay, and then something that's a perfect cube that divides 24, that's also 8. 24 is 8 times 3. Okay, cube root of 8 is 2, so I will get 2 times the cube root of 5. Okay, and then here the cube root of 8 is also 2. Okay, so sometimes the question is, if this 2 is this 2 and this one is the cube root of 8, what do I do with these two numbers? Well, this is multiplication, so you multiply them together. Okay, so this would give me minus 4 times the cube root of 3. Okay. Again, you can't combine these because they're unlike terms, right? They're both cube roots, but they have different radicands, so you're unable to combine them. Okay. All right, let's look at another type of multiplication. Okay, so we have two things with two terms, right? Two binomials. So we are just going to do distribution. So we'll have root x times root x. Okay. Then we'll have root x times 3. Okay. Then here we'll have negative 3 times root x. Okay. And then we'll have negative 3 times 3, so negative 9. Okay. Here we're going to multiply by multiplying the radicands. X times x is x squared. Okay. And these two like terms, right, are actually going to cancel out. So plus 3 minus 3, okay, these two will cancel. We'll be left with the minus 9. Okay. Now, the square root of x squared is x. So this would be our final answer, x minus 9. Okay. All right, let's do one more example. Okay. So the first thing that I want to remember is when you're squaring something with two terms, it's really beneficial to write out what you're doing. Right? You are multiplying this thing by itself. Okay? And then we're going to do the same thing that we did in the last one, and we're just going to distribute. Okay, so we'll have root 5 times root 5. Okay. Then we'll have root 5 times root 2. Okay. Then we'll distribute here, and we'll have root 2 times root 5. Okay. And then here we'll have root 2 times root 2. Okay. And we're going to simplify all of these by multiplying the radicands together. So 5 times 5 is 25. Okay. Here I'll get root 10. Here I'll also get root 10. Okay, and here I'm going to get root 4. Okay. Now, the square root of 25 is 5. Root 10 can't be simplified because there's nothing that's a perfect square that divides 10. Okay, and root 4 is 2. Okay, so my last step is to add my like terms. 5 plus 2 is 7. Okay. And 1 root 10 plus 1 root 10 is 2 root 10. Okay. All right. In the next video, we're going to cover adding and subtracting. Even though we did a little bit with this example, we'll do some more in the next example, and we're also going to cover rationalizing denominators. So I will see you guys soon.